Hello again, it's Linux Robot Geek, and this time I'm going to show you how to build your very first ESP32 robot. I will show you how to set up using the Arduino IDE, adding your ESP32 board, and showing you the wiring and the code to run your first robot. Let's begin. Before we begin, we need to have the Arduino IDE installed in our system. Now, depending on which system you use, whether it's Windows, Mac, or Linux, you will have to install the IDE directly. Now, I already have it installed on Ubuntu, so once you have it downloaded, it will show up like this. Now, this is different from the original IDE. Of course, you can always use the original if you want. Now, before we begin, we have to install our ESP32. So in order to do that, we need to add this to our board managers. This JSON, which I will link in the GitHub accompanying this video, you will have to add this to the board manager's URL. Once that's done, you press OK. Then you go to Tools, and then you go to Boards Manager. Now in this case, I already have it set up as a Node 32S, but if you didn't, you go to Boards Manager, click on here, and then type in ESP32, and it should be set up there. Once you have it set up there, then you can go to boards again and make sure to select the one you have. So go to ESP32 and then pick the board that best suits you. For example, you have a SparkFun or a Magic Bit. Make sure you pick the one you have. Once that's done, you go here. And of course, you will pick the USB port your ESP32 is on. Now, of course, mine is not connected at the moment, but if it was, it would show up as USB 0 or USB 1, depending on which port it is in. Once you do that, it will show up as connected, and you should be good to go. So next, let's talk about the wiring we are going to set up for our robot. Welcome back. So this is the wiring diagram that we're going to be using. I'm using Fritzing, as you can see. So this is the Node 32S that I'm using. Of course, if you're using a different one, make sure you use that board's wiring or pinout. Of course, you can always change the pin numbers if you want. If you have a different board, it's totally up to you. So in my case, first I would have to plug in the power to the 12 volts of the L298N, and then the negative side to the ground. Now I'm using an L298N, but you can use any motor controller you want. Just make sure to make the needed adjustments. Then I connect the ground from the ESP32 to ground. Then I connect the motors from each side to the motors in the motor terminals. Now initially you will have to connect the 4 motor pins here to 4 of the pins on the ESP32, and that's because you want to test the motors first before anything else. So in this case, I am connecting the first set of pins to 27 and 26, then the next ones to pins 33 and 25. Now we also have PWM at pins 14 and 32, but you can add those after you test the motors first. And the reason for that is you want to make sure the motors are working first. So you make sure you add the jumpers here. And that's it for the wiring. Other than that, you can use a micro USB external power supply to power the ESP32, and you should be good to go. So let's begin. Welcome back. So here is Linus all set up. I have the motor pins connected to the L298N as shown in the wiring diagram. I have the PWM connected as well. One thing I did not show is I also have on this side 3.3 and ground, as well as pin 2 connected to to the LEDs, as you can see. So if you see in the front, let me show you a little bit more. I have some LEDs which I've connected. So one set of LEDs will be connected to the 3.3 volts, so it will turn on when the ESP32 is on, and the other one is connected to GPIO pin 2. And that will be used to blink. Of course, that's optional. You don't have to add that, and you don't have to add the other LEDs. You can always just have the motors connected and that's it. But I just wanted to show you there's an option for that. Also, yes, there are two breadboards because this one was too wide for my main breadboard. So if your ESP32 is thin enough, you can just get away with using one breadboard. You can also use a circuit board or even a perf board if you want. And you don't have to use that power supply, which I have under there, which is not very neat. You can use a LiPo battery if you wish. So it's all up to you, construct it however you want. And yes, I had planned to use a servo arm, but that will be for another day. But this is the basic and very messy wiring. So let's get to the code. Welcome back again. And this time we're going to look into the code to get our motors working. Now this is called motor test, and I will provide this in the GitHub again accompanying this video so you can test the motors first. So I have four integers, and these are called in1, in2, in3, and 4, and they are defined by the pin numbers that I had defined in the wiring diagram. In the setup, I set them all as outputs, and then I create five functions. The four functions make the motors move forward, backward, left, and right, and the last function turns off all the pins. Then of course I will go forward for 1 second, stop for 1 second, go backward for 1 second, stop for 1 second, go left for 1 second, stop for 1 second, go right for 1 second, and stop for 1 second, and this will repeat several times. Now I've tested this already, so it's important to test your motors before you do anything else. And once you are confident that the motors work, you can proceed to the next step, which I will show in the next piece of code. So let's get started with that. So here is the main code we are going to be using. So I will go through this line by line. First, we will include Wi-Fi H, which is necessary. Then we include all the pins here. I added pin 2. You can just exclude this if you don't have an LED. Then of course we need a frequency, which is 2000. We'll need an LED channel, which is 0, and a resolution of 8. But again, you can modify these as you wish. We'll need our credentials. These are placeholders, so you add your SSID and your password. Make sure you set up the server at port 80. We add our header, and then we'll have our value string, which will show the value of our PWM. Then we have our two duty cycle variables. Then we have our current time, our previous time, which is at 0. Then we'll set up our timeout time to 2 seconds. Then we will set up our LED channel, frequency and resolution. We'll attach both of the EN1 and EN2 PWM pins to LED channel. Then we'll set these to output. All 5 of these will be set to output. Then we'll start our serial console. So what will happen is in the serial console it will say connected to, and then it'll print the SSID. Then it'll start by using the SSID and password. Now if it's logged in to the password to the Wi-Fi correctly, it will say Wi-Fi connected and then give an IP address using a local IP. And then the server will begin. Then you would go to the IP address of your server and it should start there. Then of course it will list for the clients, and then it'll set up the current and previous times. It'll say the new client, so every time it's connected a new client will begin. So if I was to go to a phone or a tablet, it will say new client detected, or new client in this case. And then of course it'll set up a while loop. And then of course it has our header and it has our HTML file. So of course it will close the connection once it's done. So here we have the header and the CSS for our main HTML file. Here we have the style. So we have a text align center. Our font family is Trebuchet MS. We have Arial, margin left auto, margin right auto as well. I also set up a button style. So in this case, font size would be 17px. Border radius will be 12px, and padding will be 16px and 32px. Then we set up our slider. We have these set up. This was set up in a tutorial that I had done previously. So we have slider. We have a WebKit appearance of none. 300px is our width. Height is 25px, and so on. So you can adjust these if you'd like. Then we have our jQuery. Our page title, you can always change this if you want. Our position display with the span, this will show the number from 0 to 255. We have our slider, which goes from 0 to 255. And our ID is PWM slider. We have the class, the slider class, which connects to our slider class here on our CSS. Then we have the function called PWM. And then we have our value string, which updates the value of the PWM. Then we have our buttons in a table, and the background is magenta, so we have forward, backward, left, and right, and blink. This is optional, you don't need to add this. And in the demo, you'll see the design of the application. And then we have our JavaScript. So here we have our document get element by ID, where we have our slider variable, which references the PWM slider ID. Then we have something called PWMP, which references the PWM position. And this will update the value using inner HTML. So when I move the slider, it changes the number. And then it will reflect this here as well using slider.onInput and then slider.value. And then we set up an AJAX setup at timeout, which is 1 second. We set up our PWM function, where we get the value plus position, and then it will close the connection there. So it will print out the value of the slider, and then we set up 1 second timeout for each of our jQuery functions. So when an ID is referenced, for example, forward, when I press the mouse, it will get it forward, and it will close the connection, and so on and so forth. And then this will be the end of the page. So here we have the get data. So if the header has the index of value, then it will reflect duty cycle 1 and 2, update the value, +1, then it will write to the PWM. I know it says servo, but it actually is PWM. Then it will give us the value of the PWM using value string. It will print a blank line. It will break out of that loop. If a new line is received, it will simply give us that line, or it'll simply just add to the end. And then we have our functions here for forward, backward, stop, left, right, on and off. In each of the pins will either be low or high. So when we press the button, we'll go forward, and if we let it go, it stops. If we press it backwards, it goes backwards. If we let it go, it stops, and so on. And then the client is disconnected. So going back to the JavaScript, with mouse up and mouse down, when we press it, it goes forward, for example. Or when we let it go, it stops. Now with touchscreens, it would be called touch start and touch end. And I do have a file for that if you wish to use a phone or tablet. It'll work just fine, but you would have to use Chrome for that. So that's it for the code. Let's get to the demo. Hello everyone, here is the demo. Now unfortunately I wanted to get this to run using my servos, but it didn't work because it kept moving the servos when I moved the PWM. So here is the main app, and I used the table to create this D-pad finally, as I explained in the code. And here is the slider. So I will move this just to give you an idea. So I will move it all the way here. So here is Linus again. So let's just move him. And there he's moving forward, backward, left, right. Now we do subtle presses. It works, so we'll blink the LED. And the other LED is also blinking as well. So let's decrease the speed a little bit to 244. And as you can see, it's a bit slower. And as you can see, it's moving. So it's a bit slower, but it does work now. So I call this a success. And that wraps things up for today. I have showed you how to get started with the Arduino IDE, how to add the ESP32 to the IDE, the wiring, the code, and the demo. As I said before, the code is available on my GitHub repo, which I will link below. Thank you for watching, and see you next time.